The Alta Airmaster Pro Station for deep biochemical purification of domestic and industrial wastewater is a modular treatment plant with subsurface installation. All the parts and construction elements of the station that are in contact with wastewater are made of corrosion-resistant material polypropylene. The station design, developed by Alta Group company, is optimized for uneven wastewater flow during the day. Wastewater first flows into the receiving chamber collector. This chamber accumulates insoluble suspended solids contained in the wastewater. Simultaneously, this chamber carries out anaerobic denitrification processes targeted to remove nitrogen from the wastewater. Overflows in the chamber collector are made in such a way that they allow the wastewater to flow with the lowest possible rates, whereby coarsely suspended particulate matter is precipitated at the bottom of each chamber. The primary precipitation collector is equipped with a unique system of sludge decontamination. Special ovicidal agent Alta is dosed into the first chamber collector in accordance with the actual capacity of the station, and completely destroys helminth parasite eggs present in the sediment within 6 hours of the arrival of the last wastewater inflow, which ensures the safety of the direct contact with the sediments, while also servicing the station and allows further use of the precipitant, for example, for fertilization production. The processes of aerobic wastewater treatments are initiated in the pre-aeration chamber. The precipitating chemical Alta in liquid form is also added into this chamber. The coagulant is dosed strictly in accordance with the actual productive capacity of the station. The coagulating agent chamber is designed to store coagulants, which is then dosed into the pre-aeration chamber. The coagulant serves to chemically bind phosphates present in the wastewater, as well as to improve precipitation efficiency in the subsequent laminar sludge precipitation chamber. Additional sludge is further precipitated into the laminar sludge settling tank. This sludge formation is caused by the action of the coagulants. The newly formed precipitate, together with the pre-treated wastewater from the pre-aeration chamber, is sent to the settling tank. Deposition of the particulate matter in the laminar sludge settling tank is up to 4 times more efficient than in any conventional settling tank. After the laminar chamber, clarified wastewater flows by gravity into the upper portion of the biofilter and uniformly distributes over the entire area of biological loading. The station implements an environmentally friendly technology of deep biological wastewater treatment with biocenosis of attached and free-floating autotrophic and heterotrophic microorganisms active under aerobic and anaerobic conditions, with automatic maintenance of the activated sludge concentration in the aeration tank and the primary settling tank. The wastewater is also saturated with oxygen at the time of its distribution. The biological filter, biofilter, is an apparatus in which the wastewater is filtered through the feed material, coated with a biological film, biofilm, formed by colonies of microorganisms. The aeration element installed in the biofilter is used for forced water saturation by using oxygen from the air. Retention of suspended particles, as well as floating biomass particles contained in the treated water, occurs in the secondary laminar sludge settling tank. The high efficiency of the laminar settling tank achieves a high quality of water treatment from suspended particles. The secondary aerobic biofilter completes the process of aerobic wastewater treatment according to the required standards of purification. The bioflora of the secondary biofilter is adapted to specific persistent contaminants contained in the wastewater. When the wastewater contains pollutants that require specific bacterial cultures for decomposition, the secondary biofilter is used for these cultures. The tertiary laminar sludge settling tank is designed to collect remaining floating biomass particles from the bioreactor. The station systems use a highly efficient mechanical design in the sorption filter. Passing through it, the filter water is purified to the required standards for suspended solids and oil products. purified water enters the pure water chamber, which collects the required volume of pre-purified water to be cleaned in the UV disinfection unit. The station is equipped with 2 high-efficiency pumps, primary and secondary, working as a group. The pumps take turns, which increases their individual lifespans. The pumps move water to the pressure filter. The pressure filter is preloaded with a special compound Alta sorbents, which facilitates the final stage of water purification, reducing the controlled substances concentrations to meet proper requirements for discharging water to the reservoirs. The 6-way valve for load washing is located on the filter. The time at which to washing starts is determined by the values on the filter pressure gauge. The UV disinfection used almost completely destroys pathogenic microorganisms. The bactericidal units contain sources of continuous ultraviolet radiation, which affects the aquatic environment through a special material in the wavelength range of 180 to 300 nanometers. During the bioreactor operation cycle, used dead biofilm, excess sludge, is detached and washed out of the biofilter body to the bottom of the chamber and to the bottom of the laminar settling tanks. Then, the excess sludge is removed by a hydraulic system for collecting and returning sludge to the sludge stabilization chamber, where the sludge undergoes the process of aerobic stabilization and mineralization. Oxygen required for the biochemical process enters into the chamber's interior by supplying air through the aerators. The stabilized sludge is returned to the receiving chamber of the treatment station. The system uses a specific hydraulic system for sludge collection and removal, developed and patented by the Alta Group company. Due to this system, the station has a self-balancing mechanism to maintain the concentration of activated sludge in the aeration tank biofilter. Collection and disposal of the sludge is executed by the program, taking into account uneven daily wastewater supply. The collected precipitate is moved into the aerobic sludge stabilization chamber, where it undergoes the final decomposition and mineralization. The combination of biological purification and chemical treatment allows guaranteeing results for a large number of parameters, as well as drastically reducing the size and cost of treatment facilities. The Alta Airmaster Pro Station, designed for deep biochemical purification of domestic sewage, provides an ideal solution for wastewater treatment for residential complexes such as hotels, resorts, health centers, residential building complexes, cottage communities, groups of residences, towns and villages, etc.